Hello, it's me, Kerfuffles. As you saw in the title, I just finished my first year of Cambridge Maths and I'm currently praying I did okay, bro. Please tell me I did okay. Okay, anyway, I've wanted to make this video for a while, so I'll talk about how I found the course and how life was in general. So, you may possibly recognize me from a certain video in which I did a street interview in Cambridge. I won't point to it, but it did go quite viral. So, you guys probably saw that I also uploaded a video on Pi Day of me reciting 10,228 decimal places of pi. This actually was something I helped organize with the Archimedean Society, in which we did a competition, and the most anyone other than me memorized was 109. And I did spend a lot of my time at Cambridge this year learning and revising pi. I found that maths was really fun in general, and I really like how beautiful it is. Going into Cambridge, I knew that I would find the maths fun as well. There's a reason I chose to do maths here and was admitted in the first place, right? But anyway, I'm forever grateful. Like, this is genuinely my happy place and cannot be overstated how everyone's so caring. Like, everyone is my back row. Like, they're so fast and I get to do the best math course in the world. Like, it's genuinely so good. And although I found some stuff challenging, as I'll mention, it's part of the fun, right? So I guess I should mention, disclaimer, none of this is official. It's just my opinion. You get the idea. So when someone says Cambridge Maths, there are two stereotypes. There's the guy who pulls an all-nighter to finish example sheets in a panic, and then there's the guy who's like a super genius and seemingly never finds it challenging and just gets every question easily, like my supervision partner. So going in, I honestly had no idea which camp I would fall into, and in the end I'd say I was like in the middle, but I was definitely closer to one side or the other for some of the courses. Like, we'll talk about that. So basically, the way it works is we have lectures, obviously, supervisions where I meet with a supervision partner and a supervisor to talk about the homework problems. So that's how it works in Cambridge, not much else to say, but the supervision system is great for me and works really well. So first of all, going in, I wasn't even sure if I could cope with living alone, especially since due to circumstances, I have to cook everything for myself, and I have to learn like basically last minute how to do that, how to do laundry and shopping, so that side of things was stressful. But if I could say anything to my past self, it would be to trust the process, since I figured it out in the end. In the first 3 weeks, I was focusing on getting settled in. Also, so here's a little tour of my college room. I won't show too much to not dox myself, but I really like my room. It's very nice. So here's wall reveal and floor reveal. Okay, that's all I want to show. So, from now on, I will talk about maths. I still love it for how beautiful it is, and I really am excited to learn as much stuff as I can in the future. Turned out that the part of the maths course I thought I would find challenging and the part I actually found challenging did not quite coincide. So the thing I thought I would find challenging going in was like from looking at the exam papers, so many questions were like, prove this theorem we learned in the course. And I just felt like, bro, like how am I ever gonna memorize this many proofs? If you're thinking, bro, like you literally memorized 10,000 digits of pi, what are you talking about? Then, well, you'd be absolutely right. But the issue is the reverse correlation between how useful something is to remember and how likely I am to remember it. So, however, because of the way I organized my math knowledge, which I'll explain later, I became very familiar with the kinds of standard tricks used, and it felt like less like memorizing. And obviously, the exams are like ridiculously hard. Like, what do you expect? It's Cambridge, but it turned out, so there were 8 courses this year, and 12 of the long questions in the past is often like around the borderline for a first, which is the best grade. And I felt like that seemed like a lot, bro. Like, how am I ever gonna do that? But what I realized, and I don't want to admit how long I took to realize this, is like if you take like if you get like 1 on my 4 weaker courses and 2 on my 4 stronger courses, that adds up to 12. So, it doesn't seem that hard when I think about it that way. On the other hand, the thing I actually found challenging this year with the course that didn't really occur to me would be such a big issue for me is the sheer difference between how one is expected to approach the pure courses and the applied courses. So for those who don't know what this means, I'll briefly explain. So pure maths is maths you do for the sake of it and for its beauty, whereas applied maths is maths you use to solve real-world problems. This is basically what I knew before going to Cambridge, but what I didn't realize is the contrast that in pure maths, we really build everything from foundations. Like, what I mean is, like, for example, consider drawing a circle or a closed loop. In pure maths, we would need to define what it means to be inside or outside the loop, even though intuitively, like, everyone kind of knows what it means. So we prove everything and we take nothing for granted in pure maths. On the other hand, in applied maths, we focus more on getting useful results. Like, as such, we don't really prove things so much. And often proofs will be heuristic arguments like at a small displacement dx, let dx approach zero, relying more on physical intuition. Sometimes stuff is just stated and used without proof, and we say like this technical details goes to use the other course, and that just makes it less fun for me personally, because like I get like if someone's proved it, then like you don't have to reprove everything, but personally I don't like to use a magic rule because someone told me like this works, trust me, bro. So like I don't like to take things on trust. So yeah, I guess if that didn't make it obvious, I indeed very much prefer pure, and oh boy, the other math students know because I low-key can't shut up about it. So it was a huge shock to me to realize that the difference between pure and applied is not only in the level of applicability, but also in the standard of proof. Now, although I am willing to assume things that feel obvious, like the example of what it means to be inside or outside a closed loop, I don't take things on trust. So this is the first of two principles I follow. The other principle I follow is that I firmly believe maths is not a subject where rules should be allowed to change based on context, and basically what this means is that even though I ought to treat pure and applied courses differently, I don't. So this basically means that I go through the extra effort to prove everything in the applied courses to a standard where I don't feel I'm taking it on trust. Well, actually, that's the first principle, but I also make sure that when I do questions in applied courses, I write whenever it's non-trivial, what conditions or theorems allow me to apply the technique in question, since I'm expected to do the same in pure rather than just using it naively, and I want to follow the same rules like universally, because math is math. Math shouldn't have like social norms, because autism and all that. Anyway, now I'll just address the title. So in the title I mentioned that I survived a year of Cambridge Maths, and I also turned it into 604 pages of notes, which is the total as of today. And I didn't mention this in the title, but I've also produced a total of 234 minutes worth of videos where I explain some math stuff that I feel is more appropriate to explain in video format. And I'll tell you in a minute where to find all that. So you can find all these notes and links to the videos on my website, maths.orger.org, which is finally finished to a standard that I can share it. And so yeah, I guess if you guys go there, you know my real name now, and you also know exactly where to learn math. So if you can't access the website for whatever reason, you can access all the files and video links by locating the GitHub repository for the website. As I go, I'll explain the structure of the website. So basically, it builds maths from the basics, like basic arithmetic, to my notes for the Cambridge course, which are ever growing, and it's almost all built from first principles, with a nuance I'll explain later. So let's talk about how I got here. So to explain how I got here, we actually have to go back to March 2025, before I even knew I'd be at Cambridge. So for reference, what we do, at least like in my school, is we do GCSEs, where we do like different subjects in like the equivalent of the first 2 years of high school. So obviously like everyone does like GCSE, like English and maths, and then if you pick the subject where you have more choice in the second 2 years of high school, you can do A-level maths, and you can also do A-level further maths if you pick that as well, which like obviously I did, because anyone doing maths at university like pretty much is gonna do further maths. So what I originally wanted to do is like to suddenly drop a video that was going to be like 12 hours long, and the video was just going to be like all of math that was going to cover everything from basic arithmetic to the equivalent of A-level maths and further maths. So on March 5th, 2025, I started work on this video, and after about 3 months, I had made the first 2 hours and 56 minutes of the video, in which I had basically explained all of pre-GCSE maths, which is maths one would learn in elementary or middle school. But then I shelved the project because building it was stressful. So like a year ago today, I had shelved video project, no written notes yet, didn't know if I would get into Cambridge, and didn't have the life skills. So it's crazy how far I've gotten in the last year. I had read ahead and looked at some Cambridge math lecture notes, but yeah, so I'm just gonna go through the maths I'd done in the past year in detail chronologically. So I mentioned I don't take things on trust, so because of this, I had been going through the effort of proving everything as I went through A-level maths and further maths. So after finishing the exams, I had the idea, you know, it would be more realistic if instead of, and like even like, this would be like a good idea because it would not only be realistic, but it would be like more like unique to me, I guess, that instead of making an all of maths mega video, I would make some documents and videos where I catalog how to prove everything in A-level maths and further maths that the textbooks don't prove. However, there were two things that resisted proof. And I had actually broken my principles and used them on my exam anyway, something that would haunt me for months to come. So these both were in the statistics parts of the course. The first was the central limit theorem, which basically in layman terms is the reason why the bell curve, a reason why the bell curve comes up a lot. And the second was regarding chi-square tests, a procedure one is expected to apply in statistics, where the thing to prove is why it makes any sense, like why the thing you calculate approximates something that only depends on what's called the degrees of freedom and nothing else. So, in the summer before I went to Cambridge, this was what I was working on. With the central limit theorem, it took me a couple of days to find a hand-wavy, not very rigorous proof, which slowly over the past year, as I realized more and more, how much rigor was needed, I've been refining that. And chi-square tests, which I have nicknamed the Wilson-Gerald-Ford theorem for reasons I won't get into here, was even harder for me to prove. This was a very long journey, and in a Google Doc, which I'll link in the description, I explain in more detail my journey to prove this, and also more details about my journey to prove the central limit theorem. So what I'll say here is that in the end, for chi-square test, I ended up with a proof that, as far as I know, I discovered, and you can find it in chapter 8 of level 6.3 in my website. If you want the honest truth, that specific section is the product of a massive agonizing psychological war, as I explained in the document I linked in the description. So please, if you find a flaw in it, send me a self-contained correction. Like, I really don't want to go back to being stuck on this. So in September, I knew by this point I had gotten into Cambridge, and I had shelved several documents and videos with proofs of things from A-level maths, as well as a video that explained arithmetic and algebra basics, the one I had made before shelving that. So I vibe coded the website and decided the structure would be as follows. So the website has levels, and they go for all of maths. So level 1 would be the 3-hour video I had made. Level 2 would be GCSE maths. Level 3 would be A-level maths. Level 4 would be proofs of everything from A-level maths. Level 5 would be A-level further maths, and level 6 would be the proofs of everything from there. Level 7 beyond would consist of my lecture notes from Cambridge, like roughly 1 level per term, but it's some nuances. It's not exactly that. It's not exactly in the same order and stuff, like I'll explain. But at this point I'd completed levels 1, 4, and 6. So most of the levels have sub-levels as well. You can check that out. Beyond level 6 though, I no longer defer any gaps to later levels. And I wouldn't even do that before level 6, but if, like, there's one reason I do, which is I want it to be that, like, someone who, just wants to pass GCSE or A-level or school maths to be able to use my website without having to sit through proofs they don't care about. But I feel like someone who's interested enough to go beyond level 6 is probably sufficiently interested in seeing the proofs. So now I get onto my maths journey at university. So in the first term, the 4 courses were courses I had read lecture notes for in advance, those being numbers and sets, which is about numbers and about sets, and while this is probably the area of maths I'm most interested in, I'm hesitant to call it my favorite course this year, as I wish it went into more depth. We also had vectors and matrices, which is about vectors and about matrices. I know, crazy. And it's technically an applied course, but honestly, I think it's actually quite pure for an applied course. And then groups, which is about groups. And if you don't know, in layman terms, groups are basically sets of symmetries of stuff. And the questions on the groups course were very challenging. And then the hard one, differential equations. So this course was hard for me because, well, first of all, it's an applied course, and I'm just better at the pure questions because, like, I can't think in the mindset of the applied mathematicians. Like, they have to be a different species, bro. Like, there's no way. Like, I'm convinced I share more DNA with my cat than I do with applied mathematicians. But anyway, so many things in differential equations were stated without proof, and so the course did not live up to the expectations I had built from reading lecture notes for the other 3 courses, which was basically the expectation that, like, the Cambridge math course would, like, build everything from the ground up. So Among the stuff I had to prove for this course in order to not have to take them on trust were the Poincare lemma, which I did by constructing a potential with the homotopy formula, uniqueness of solutions, which I did by clever arguments only for the cases we actually used to avoid proving general theorems that may be super complicated to prove, convergence of series solutions, derivation of logarithmic series solutions, continuity of level surfaces, although that was actually later moved to level 6 to justify implicit differentiation from A level, properties of partial derivatives like symmetry and the chain rule, and differentiation under the integral sign. And it turned out that the tools I had built, like when proving stuff from A-level further maths, were very useful, and that by doing all this, the analysis course from the second term was essentially trivialized for me because I was forced by my principals to go way beyond that course, so to me, the analysis course low-key felt like basics. So that was a course in the second term. In the second term, we also had a probability course, which is technically pure, but the second half is basically applied, and a vector calculus course, which is very applied, as I'll talk about later. And I think there was a fourth one, I can't quite remember. Now in Christmas break, there were 3 main things I did. So, first thing I did over the Christmas break, I had a section of my website called MISC Results where I would put maths I know that didn't directly fall into the curriculum. So examples of stuff I've proven there so far include number theory stuff like Bertrand's postulate, which states that given any number n greater than 1, there's a prime number between n and 2 times n. I also included a topological proof that there is no quintic formula, and the construction of some pathological analysis functions and proof that they work, and a second proof of chi-square test, the Wilson-Gerald-Ford theorem from earlier. Because as I mentioned in the document in the description, I actually ended up proving it in 2 ways. Now, the second thing I did over the Christmas break, so at this point, levels 1, 4, 6, and 7 were done, 7 being from the first term of Cambridge, like my lecture notes. But the gaps, which were levels 2, 3, and 5, were getting really annoying, so I wished I could just, put in the textbooks, but obviously, that's illegal, and more importantly, I wanted the website to be my own. So I tried asking ChatGPT to basically make textbooks for me, but they were not the best, as I'm showing on screen. So I realized I basically have to type them myself. It's an agonizing, boring process, took forever, but I had some fun making fun of the official textbooks as I did it, as you can see if you read level 5 in particular. And the gaps are filled in, so now I've in fact finished the first 8 levels of the website as of making this video. So, third thing I did over the Christmas break. Vector calculus, I mentioned it was applied, and so I was trying to make it rigorous, but my approach to making it rigorous was a big mistake. So I picked up a book called Analysis on Manifolds by James Munkries, and I was trying to read a graduate level book, and I was definitely not ready for it. So I got through about half of it before giving up, and I would eventually make the course rigorous by a combination of what I did manage from the book and other means like, Googling stuff, asking AI, whatever. So the big mistake I made was to not only try to read that book way before I was ready, but to try to read a book like that just to fix a vector calculus course, and not because I genuinely wanted to, read it. So next time I'll stick to lecture notes for analysis courses that I want to take anyway, and they're more geared towards teaching, and I'll stick to books that are undergraduate friendly. So let's get to term 2. We had the 3 courses I mentioned above, and the 4th one, which is the physics course, which I kind of gave up on since, there's nothing wrong with it, but it isn't for me. So I didn't seriously attempt it in the exam, so basically for my purposes, there were 3 courses in term 2. But there were also 2 courses from the second year students that I attended lectures for, those being complex analysis and groups, rings, and modules. And I found that attending second year courses was one of the most fun parts of the year, as not only were they more interesting, but when I would skip my lectures to go to complex analysis, I felt so cool, realizing I can just go to whatever I want. It's really a beautiful place. So here's what happened, right? After the second groups, rings, and modules lecture, I found myself wishing I could stay for the other lectures as they were more interesting than mine, in my opinion. But then I realized, wait, who's stopping me? So I proceeded to start going to complex analysis, and the realization absolutely nobody is stopping me. It was a crazy feeling, bro. So, vector calculus, the applied one. So what I didn't anticipate was that it was actually applied in a slightly different way from the differential equations course from the first term. So in the differential equations course, they would state a result and not prove it, but in vector calculus, like, they would give an intuitive argument for why you'd expect it to be true, which honestly, I think they could have done more of that in differential equations, but that's besides the point. Vector calculus, they would show, they would like call these like heuristic arguments a proof, which like a pure mathematician, like, it's cringe so hard, like, and then they would do something infinitesimals, which, to be albeit honest, like, to me it was just complete nonsense. So in differential equations, I felt like it was more like transparency about what the gaps were, and like if I were to take things on trust, which I don't, I could like actually trust them. But obviously, like, I'm not here to criticize the course, I'm just here to talk about like how I found it. Like, this course is the best course in the world, like these, like, yeah, I'm just nitpicking. So in vector calculus, I'll tell you what I had to prove. I had to prove the change of variables theorem, divergence theorem, Stokes theorem, Green's theorem, the formulae for div, Gradon curl, and Laplacian and other coordinate systems, the fact that zero curl implies path independence, which the lecturer sketched a proof of, but glossed over some details about smoothness. As for probability, I had to prove uniqueness of moment-generating functions, and it turned out that a lot of my work from proving the central limit theorem helped. And as it happened, going to the complex analysis lectures also helped. So level 8 consists of my notes for the 3 courses from the second term, complex analysis, and my notes from like the parts of that book I did manage. As for groups running through modules, those notes are actually part of level 10, which complex analysis would have been as well if not for the fact that it was useful for the probability course. So yeah, those are all the courses. Now I'll talk about how the exams went. So as I mentioned, 12 long questions fully solved, if you get the alpha quality mark on them, which basically means you fully solved or almost solved them, maybe, with a minor mistake, plus a few short questions, is usually around borderline for a first. And the good news is I think I got 14 longs, 10 shorts, and 2 longs almost solved, which means I think I have a decent chance of getting a first. Hopefully, bro. Like, I pray to God I do. Like, secretly hoping I get ranked 67 or 69, because, I actually feel like I've done about well enough for that. But if I get 68, at least I could say, like, oh no, I missed greatness by 1 in 2 different ways. But I guess we have to just see what happens. I just want a first, bro. Like, I guess if I don't get it, it doesn't really matter. I'm here to learn maths and not just to do exams. So as for this year's exams, overall vector calculus was easier than I expected, but numbers and sets was harder than I expected. And every other course, I'd say I found it about average. So I'm just always going to be upset that on one of the differential equations long questions, I messed up -1/3 times -4 after writing, praying I don't make any silly mistakes before I did that part of the calculation, which is pretty ironic. And it was after my supervisor told me that in that course they were very harsh with silly mistakes, so can't get that out of my head, bro. Please, I pray to God I get the alpha for that question. Anyway, yeah, exams are done now, so I'm hoping I did well. I have a lot of work to do over the summer for next year, and I'm looking forward to going on to, like, more interesting maths. So yeah, I just wanted to give this quick life update. See you guys.